Hello and welcome back. And in this video, we're going to be looking at another very popular interview question, and this one is related to queue. It clearly says it's queue-related question because queue is part of the question. So the question goes, how would you build a queue using stack? Okay, so it's literally that is the question, and it's been very popular because it checks you for basic understanding of how queue operates. So not only the FIFO operation, first in, first out operation, but you also need to work with last in, first out. So you need to build out a stack, and you need to know inner workings of stacks as well before you actually solve the problem, because you're going to be building a queue using stack. So that is the question. So I would actually say pause the video here and try to solve this. Come up with your own algorithm and see if you can actually think a solution, and then unpause the video to see what we've got for you. Okay, so pause the video here. All right, hope that went well. So let's go ahead and take a look at the solution that we've got waiting for you. So in the last video, we actually covered generic stacks. So we're going to look at two different variations for building a queue using stacks. Okay, so there are two approaches. First approach is basically building a stack where your enqueue operation is extensive. That means you're going to be, first of all, you're going to be using two stacks to keeping a track of enqueue and dequeue. So when you're using two stacks, the idea is that basically, let's say if you have stack 1, you have items 1, 2, and 3. You're going to push them into the stack, but you want to bring them out in the same order. So what you do is you create two stacks for the queue. So sorry, okay, let me repeat that. This is the array, this is the data. You want to put 1, 2, 3 into a queue. Okay, that queue is built using stack. So what you do is you build two stacks, right? So first stack is actually the enqueue operation. Okay, so what it does is basically it says whatever you have in stack 1, push that into stack 2, and then insert the newly found element into the stack 1. So for example, let's say we have 1. We are operating on 1. We insert 1. We first check this is a stack 1. So S1, okay, and this is S2, okay, S2, all right. So when we need to insert 1 here first, right, 1 is going to go, first we're going to check if the stack 1 is empty. So we can say, yeah, it is empty. So we're going to put 1. That's it. That's it for the operation. Now, when it comes to 2, we're going to go check first if the stack 1 is empty. It's not empty. So we're going to take that 1 and move it into stack 2. Okay? And then we're going to take this 2 and move it into stack 1. All right? And next operation is move this item, whatever item we have in S2, and put it into stack 1. Okay? So this is now in the same order. So given that, like, this is the head and this is the tail, or you don't care about tail and stack, when you actually DQ, you're going to DQ 1. Yeah, because DQ was entered first, so DQ should go out first. That's the queue's principle. So 1 is going to go out, and then 2 is going to go out. So your DQ operation is going to operate on this stack, but you're using the second stack actually to help you sort those elements properly. Okay, so let's take a look at the code, and it's going to be more clear as we write the code. So we're going to use queue stack 1.script, create a new file. Going to create class queue stack 1 of type T. Going to create two private stacks, private variable stack 1 and stack 2. Okay, we're also going to create is empty. And here we're simply going to check if the stack 1 is empty or not, right? Stack 1 is never going to be empty if there's any element, because uh, that's the that's the view we are operating on most of the time. I mean, that's the stack we are operating on most of the time. So Enqueue operation is going to take data of type T, and what we need to do is we need to say while stack one dot is empty. So while it is not empty, right, in the Enqueue operation, move everything in stack 2. Like so. Okay? So you're going to move everything in stack 2. Then we're going to take our stack 1 and push on that. Okay? And once we have pushed that item, we're going to restore the order. So the way we restore the order is we actually reverse that operation. We are going to say while not stack 2 dot is empty. We're going to say stack 1 dot push stack 2 dot pop. Like so. Okay? So this is going to actually keep us stack 1 in the same order as the item arrives. That way we can actually, when we pop out, it's going to be popping out in first in, first out order. Now we're going to do DQ, and DQ is going to be very simple. DQ is simply going to be stack 1 dot pop or return nil. Okay. So DQ is just going to be basically taking the stack 1 and popping the first item from the stack. Now if you go to our main method, I'm going to just remove this and going to create a queue using queue stack of type int, and we're simply going to say for I in 0 to 10 queue dot enqueue, and we're going to insert I in there, and we're going to say while queue is empty, while queue is not empty, print DQ. Right? So if you run this right now, as you can see, we inserted 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we got the same order back. Okay? So once again, this is how you can actually build a queue using 2 stacks by keeping Enqueue operation extensive. Now in the next video, we're going to take a look how we can actually reverse this and keep the DQ as expensive and keep Enqueue very light. The choice is going to be then yours when you're building your data structure out. Is basically when which operation is the most frequent, and you can actually reduce the time complexity based upon that. Okay, so I'll see you guys in the next video, and we're going to build out the second form of this this queue stack problem. Okay, so I'll see you guys in the next video. Thank you.